Okay, so for this one, the first thing it asked you was to find the domain and the range. And this one, it's not too hard to find the domain. The range is a little bit harder. So one way you could have done this is wait, if you found the inverse, then you could find the domain of the inverse, and that would be the same as the range of this one. So for now, let's just look at what the domain of this would be. Since this is a rational function, we're just looking at what we would have to leave out. That would be anything that would make the denominator 0. So what we would have to leave out would be 1. Domain would be that x is not equal to 1. If we want to write this as an interval, this would be from -infinity to 1, and then from 1 to infinity. So let's come back later and talk about the range. Okay, and then the next thing you were supposed to do was actually find the inverse of this one. So for that, this is going to be that process we were talking about yesterday. We want to start out by just writing this as an equation. So instead of the f of x on this side, just write it as y. And then you switch the x's and the y's. So this y we're going to replace with an x, and both of these x's over here we're going to replace with y's. Now the hard part of this is actually solving it for y. So this is just a rational equation like the ones we were talking about in the last unit. Since this we could write as x over 1, that means we could cross multiply. I'm going to put both of these in parentheses so that when I multiply, I've already got the parentheses there. So on this side, I'm going to distribute the x. Now, since I'm trying to solve for y, I want to put all my y terms on one side and everything else on the other side. It really doesn't matter which side you put which thing on. So I'm going to make this side the one for my y terms. And over here, I'm going to put my non-y terms. So that means I want to move this term over to this side. And this term doesn't have a y, so I want to move it over to that side. So to move this one, I'm going to subtract 2y from each side. That would give me xy minus 2y. And to get rid of this one, I'm going to add x to both sides. So that gives me on this side just 3 plus x. Then over here, since I've got two terms that both have y, I'm going to factor out the y. And then I can divide out this entire factor. So I'm dividing both sides by the x minus 2. On this side they cancel, so now I have y equals 3 plus x over x minus 2. So there are a couple different ways you could have written this. You could have also written it as x plus 3 over x minus 2. And depending on which side you put things on, you could have gotten something like, let's see, negative x minus 3 over 2 minus x. Anyway, any one of these would be your inverse function. So I'm just going to write it this way. So my inverse would be x plus 3 over x minus 2. Okay, now that we've got that, it's asking us to find the domain and the range of this one. We already know what the range would be because we found the domain of the original function up here. Remember, we switched the domains and the ranges. So for this one, we can already fill in the range without having to do any work. And now we can look at this one and find the domain. For this, we'd have to leave out 2 because that would make the denominator 0. So our domain for this is going to be -infinity to 2 and 2 to infinity. And now that we have that, we can go back and fill in the range for our original function. So I'm going to go back up here and fill this in like that. So remember, when we do the inverses, these two get switched. So for this one, all we have is the graph. So for this, if you're trying to find the domain and the range, Remember, from the domain, for the domain you want to go left to right, for the range you want to go bottom to top. So for this one, for our domain, if we start from here, we don't get to any points on the graph until this one. So our x values start at -4. So that's going to start at -4, and then it goes along until here. At this point, it drops down to here. So there's no gap in the domain there because it goes right from this point down to this point. And then it goes along and it stops at this one. The x value for that one is 4. So our domain is going to be from -4 to +4. And then for the range, we're going bottom to top. This time we're looking at the y values. So the first point we're going to come to is this one. The y value for that is -2. That's where our range is going to start. And then this one, if we keep going up, there is a gap between this point and this point. So our range is actually going to be 2 different intervals. So we come up to this point. So this part stops at this point. Our y value there is 1. And then it jumps up to here. So it starts again at this point, and our y value there is 2. And then it goes up to here. This is our highest point. The y value for that is 5, so that's where our range ends. And notice for this one, I put a parentheses with the 1 because this one was an open circle. So it's not actually including this point. That's where it jumps up to this point. Then, did anybody have questions about graphing the inverse for this one? This was one of those things, if you just take the points that are labeled on here, just switch the x's and the y's and plot those points and then connect the dots pretty much. And then when you go to do part C on this one, for the domain and the range of the inverse, you can take the domain and the range for your original function and just switch those two. All right, so first if we just graph this whole function, 5 minus x squared, and this you could have graphed with your calculator and then just transferred the graph to here. So this is going to be a parabola that's opening downward. Something like that, and it asks you to label at least 3 points. So here's one at 0, 5. That point was -2, 1. And here's another point at -2 or +2, 1. But for the domain of this one, we're thinking about what numbers we could plug in for x. That would be anything. So our domain for this one is going to be +∞ or -∞ to +∞. And then for the range, if you have the graph, you can look at the graph. So if we go from bottom to top, this is going to go all the way down. So the range is going to start at -∞. And then our highest point on the graph is this one. So that's at where y equals 5. That's where our range stops. Then the next question it asks you is whether this is a one-to-one function. Remember, for that we were doing the horizontal line test. There are lots of places here you could draw a horizontal line that would intersect the graph twice. So the answer is no, it's not one-to-one. So this is like the one we were doing yesterday where we erased part of the graph to make it one-to-one. That's what it's asking you to do here. So we could think of a domain restriction. So in other words, just take part of this graph and erase it so that we'd have something that was one-to-one. So you could have done the right half of the parabola, which would mean you'd be going from 0 to infinity for your x's, or you could do the left half. So you could go from -∞ up to 0, or you could have even taken smaller pieces than that. As long as whatever you have left is one-to-one, that's what matters. So let's say we're just doing this from 0 to infinity. So in other words, we're changing the domain from what it would have normally been. We're saying we're going to make it only this part. So if I was going to redraw this graph after I restricted the domain, that would mean I'd be erasing all of this part over here. So we're only looking at this half of it. Then we're trying to find the formula for the inverse. So I'm going to use that same process we talked about. So I'm going to write this as an equation, and I'm going to switch the x's and the y's. And now I want to solve this for y. So first I'm going to get the y squared by itself on one side. So I could start by subtracting 5 from each side. That gives me a negative y squared. I still need to get rid of that negative, so I'm just going to multiply both sides by a negative 1. So I'm going to take this whole side times negative 1 and this side times negative 1. That's going to change this to a negative x plus 5. When I distribute that negative, it'll change that to a y squared. And I think in the answers I probably wrote this as 5 minus x, so I just switched the order of those two. So now we want to do the square root of each side so that we can get this to be just y instead of y squared. So here's where we have to think about doing plus or minus. So we have to figure out which one of those is going to give us the actual inverse of the graph that we chose over here. So if you chose a different domain restriction, you might end up with a different answer for this one. But one thing you could do to figure this out is just graph it on your calculator. So if we think about what we want this inverse to look like, if we take this graph and reflect it across the line y equals x, or if we just take some of these points and switch the x's and the y's, we're going to get something that looks like that. So that's, if I put this on my calculator, this is the graph that I want to see. And all I'm trying to figure out right now is whether I want to have just the square root of 5 minus x or if I want to have a negative in front of it. So I'm going to start by graphing just the square root without the negative in front. So yeah, that's giving me the graph that I wanted here. So if I had chosen the other half of my parabola in the first place, then I'd be using the negative in front of the square root. Okay, so that means that my actual inverse function is going to be just the square root of 5 minus x. Okay, and then we want the domain and the range for the inverse. Actually, we should be able to do this without doing any more work because we've already got the domain and the range for our original function. And we have to use the domain restriction that we had here. So our domain is going to be negative infinity to 5. And our range is going to be the domain restriction that we had up here. And that should fit with what we're seeing on our graph. So if you did the graph of the inverse function, that should match with what we see here. So this one, our domain would go from here and it would stop at this point. So it would stop at 5. The range would start here at 0 and go up.